Hello, calculus students. In this problem, we're going to evaluate this limit as h goes to 0. Here we're actually computing a derivative of 5 over x at the point a. In other words, we're computing the instantaneous rate of change at some given point a. A is a parameter. You treat it just like a number. H is the term that's going to 0. Okay, in the first step, we need to find a common denominator. So the common denominator is the least common denominator between these two terms, and that is the product of the denominators, a times quantity a plus h. And we need that under both terms. So we multiply the numerator and the denominator both by a on that term on the left, and on the term on the right, we multiply the numerator and the denominator by a plus h. Now, in the next step, don't cancel these out because you want them to stay there. You're trying to utilize these to reduce the numerator. All right, now you see that we're multiplying by the 1 over h. This 1 over h comes from this h here. Dividing by h is the same as multiplying by the reciprocal of h. If you need a refresher, just recall this maneuver with this fraction. 3h divided by 5 is the same as 3h divided by 5, which is 3h times 1/5, the reciprocal of 5. Okay, in the next step, here we are. We have our common denominator, 5a minus 5 times quantity a plus h. Now notice that the minus sign goes with this term in the numerator. The denominator is the common denominator a times a plus h. So since we have two of those, I'm just going to combine the numerator over the single common denominator. The 1 over h comes along for the ride, and so does the limit symbol. Then in the next step, some cancellations are going to occur after we distribute the minus 5. So the minus 5 gets distributed. Now notice the minus 5 gets distributed to both terms, not just the a term, but the h as well. So it's minus 5 times a plus minus 5 times h. 1 over h comes along for the ride, so does the limit symbol, and we leave the denominator alone. Then in the next step, our cancellation occurs that we were promising. The 5a's cancel out, and you're left with a minus 5h, this term here, in the numerator. The 1 over h comes down, and there's our common denominator. And we'll get another cancellation. These h's will cancel, and since the h's cancel, we're left with a minus 5 in the numerator, and the denominator is a plus h, and then we just simply evaluate the limit. We let h go to 0, so we plug in the 0 there. No harm in doing that now because the denominator will not be 0, and we'll end up with minus 5 over a times a, which is a squared. Remember I mentioned there's no harm in letting h be 0 here. If you let h be 0 here, you'd have 0 in the denominator, but you'd also have 0 in the numerator too, because without this h term here, you'd have 5 over a minus 5 over a. And remember, 0 over 0 is an indeterminate form, so you have to do something like reduce this fraction or do some kind of factorization in order to get the numerator and denominator to cancel, so you didn't have 0 over 0. Okay, so it turns out that the derivative then here of 5 over x, you'll see is minus 5 over x squared, and then if we substitute the parameter a in, we'll have minus 5 over a squared. Okay, but more on that later. This is the process of evaluating this limit to get this result. All right, good luck.